Prior to the 1975 National Electrical Code, it was common to install an electrical service without a main disconnect located outside of the building. Each apartment would have an individual main load panel. The service entrance conductors would then be terminated directly to the bus bars inside of those individual panels. In order to energize the entire building, it was necessary to open all of the breakers within each apartment. The 1975 National Electrical Code introduced a requirement for a service disconnect to be located at a readily accessible location outside of the building. This requirement is contained in Section 230.70, which states where the service equipment is located outside the building, there shall be a disconnecting means for each service readily accessible and within sight of the service point. The disconnecting means shall be capable of disconnecting the service conductors from the service entrance conductors. Based on this information, it is clear that after the 1975 National Electrical Code was adopted, it was no longer allowable to have a service without a main disconnect outside the building. The service disconnect was then required to be readily accessible and also within sight of the service point. Therefore, a building constructed circa 1960 or earlier, it is likely that the electrical installation was compliant with the National Electrical Code at the time of its construction. However, if the building has not been updated to adhere to current codes since then, it would now be a violation of the current National Electrical Code to not have a service disconnect located outside the building. To elaborate further on service disconnects, let's look at some specific requirements. Firstly, the location needs to be readily accessible, meaning it should be easily reachable without requiring tools to get to it or having to climb over obstacles. Secondly, it needs to be within sight of the service point. This means the disconnect needs to be visible from where the service conductors enter the building. The purpose of this is to ensure that anyone disconnecting the power can visually confirm that they are disconnecting the correct service. Thirdly, the disconnect must be capable of disconnecting all service conductors. This usually involves a single main breaker or a switch that interrupts all ungrounded conductors simultaneously. Now, let's consider some of the implications of these code changes for older buildings. If a building was built before 1975 and has not been updated, it likely does not comply with the current code regarding service disconnects. This doesn't automatically mean the building is unsafe, but it does mean it's not up to current standards. There are several reasons why updating the service disconnect is important. Firstly, it improves safety. Having a readily accessible disconnect allows emergency responders, such as firefighters, to quickly de-energize the building in case of a fire or other emergency. Secondly, it simplifies maintenance. A main disconnect makes it much easier and safer for electricians to perform maintenance or repairs on the electrical system. Thirdly, it ensures compliance with current codes, which can be important for insurance purposes or when selling the building. When considering an upgrade to meet current code, there are a few options. One option is to install a new service disconnect outside the building, near the meter stack. This would involve running new conductors from the meter stack to the disconnect and then connecting the existing service entrance conductors to the disconnect. Another option is to install individual disconnects for each apartment at the meter stack. This would involve replacing the existing meter stack with a new one that includes disconnects. The best option will depend on the specific circumstances of the building, including the layout of the electrical system and the available space. It's important to consult with a qualified electrician to determine the most appropriate and cost-effective solution. Now let's delve a bit deeper into the technical aspects of service disconnects. The National Electrical Code specifies the requirements for the size and type of conductors used for service entrances, as well as the overcurrent protection required for these conductors. The size of the service entrance conductors and the overcurrent protection must be adequate to handle the calculated load of the building. The calculated load is determined by adding up the loads of all the individual circuits in the building, taking into account demand factors, which allow for the fact that not all circuits will be operating at full capacity at the same time. The National Electrical Code also specifies the types of wiring methods that are permitted for service entrances. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and cable. The choice of wiring method will depend on the specific application and the local code requirements. In addition to the requirements for the service entrance conductors and overcurrent protection, the National Electrical Code also specifies the requirements for grounding and bonding of the electrical system. Grounding and bonding are essential for safety, as they help to ensure that the electrical system is properly grounded and that any fault current will flow back to the source, tripping the overcurrent protection and preventing electrical shock. The National Electrical Code also includes requirements for labeling of electrical equipment. All service disconnects must be clearly labeled to indicate what they disconnect. This helps to prevent confusion and ensures that the correct disconnect is used in an emergency. Let's also discuss some of the common issues that arise when dealing with older electrical systems. One common issue is that the existing wiring may be undersized for the current load. This can be due to the fact that the electrical load of the building has increased over time as people have added more appliances and electronic devices. If the existing wiring is undersized, it can overheat and cause a fire. Another common issue is that the existing wiring may be damaged or deteriorated. This can be due to age, moisture, or physical damage. Damaged or deteriorated wiring can also be a fire hazard. When upgrading an older electrical system, it's important to carefully inspect the existing wiring and replace any wiring that is undersized, damaged, or deteriorated. It's also important to ensure that the grounding and bonding system is up to code. In some cases, it may be necessary to replace the entire electrical system in order to bring it up to current standards. Furthermore, it's essential to understand the concept of grandfathering in electrical codes. Just because an older installation doesn't meet current code doesn't automatically mean it needs to be upgraded. The concept of grandfathering allows existing installations to remain in place as long as they were compliant with the code at the time of installation and do not pose a safety hazard. However, if the electrical system is modified or expanded, the new work must comply with the current code. In the case of a 4-apartment building with individual main log-only panels and no disconnects outside, the installation may have been code compliant when it was originally installed. However, as previously stated, if any modifications or expansions are made to the electrical system, a service disconnect must be installed outside the building to meet current code. Additionally, even if no modifications are made, there may be situations where an upgrade is recommended for safety reasons. For example, if the electrical system is showing signs of deterioration or if there have been any electrical incidents in the building, an upgrade to install service disconnect may be warranted. To further clarify the requirements for service disconnects, let's look at some specific examples. Imagine a scenario where you have a detached garage that is fed from the main service panel in the house. In this case, the National Electrical Code requires that the garage have a disconnecting means located either inside or outside the garage. The disconnecting means must be readily accessible and capable of disconnecting all ungrounded conductors that supply the garage. Another scenario is where you have a separate building on the same property as the main building, such as a workshop or a shed. In this case, the National Electrical Code requires that the separate building have a disconnecting means located either inside or outside the building. The disconnecting means must be readily accessible and capable of disconnecting all ungrounded conductors that supply the separate building. Furthermore, the disconnecting means must be rated for the ampacity of the circuit that supplies the separate building. Another important aspect to consider is the type of overcurrent protection used in the service disconnect. The National Electrical Code allows for the use of either fuses or circuit breakers for overcurrent protection. Fuses are one-time devices that melt and interrupt the circuit when an overcurrent occurs. Circuit breakers are reusable devices that trip and interrupt the circuit when an overcurrent occurs. The choice between fuses and circuit breakers will depend on the specific application and the preferences of the electrician. However, it's important to ensure that the overcurrent protection is properly sized and rated for the circuit that it protects. In addition to the technical requirements for service disconnects, there are also some administrative requirements that must be followed. In most jurisdictions, a permit is required before any electrical work can be performed. This is to ensure that the work is done safely and in accordance with the National Electrical Code. The permit process typically involves submitting plans to the local building department and having the work inspected by a qualified electrical inspector. It's important to obtain all necessary permits before starting any electrical work. Now let's discuss some additional considerations for multi-family dwellings. In a multi-family dwelling, such as an apartment building, there are often multiple services, one for each apartment. In this case, the National Electrical Code requires that each service have its own disconnecting means. The disconnecting means must be readily accessible to the occupant of the apartment that it serves. The disconnecting means must also be labeled to indicate which apartment it serves. In some cases, it may be possible to group all of the service disconnects together in a common location, such as a meter room. However, the disconnects must still be readily accessible to the occupants of the apartments that they serve. Also, to expand upon safety considerations, the location of the service disconnect should be chosen carefully to minimize the risk of accidental contact with energized parts. The disconnect should be mounted in a dry location and should be protected from physical damage. The disconnect should also be located away from flammable materials. It's also important to ensure that the disconnect is properly grounded and bonded to prevent electrical shock. Proper grounding and bonding helps to ensure that any fault current will flow back to the source, tripping the overcurrent protection and preventing electrical shock. The National Electrical Code specifies the requirements for grounding and bonding of electrical systems. These requirements are designed to protect people from electrical shock and to prevent fires. When working on electrical systems, it's important to always follow safe work practices. These include wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. It's also important to de-energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies the circuit. Before de-energizing a circuit, it's important to test it to make sure that it is not energized. This can be done using a voltage tester. If the circuit is energized, do not work on it. Find the source of the power and de-energize it. After de-energizing a circuit, it's important to tag it out. This involves placing a tag on the circuit breaker or fuse that indicates that the circuit is being worked on. This helps to prevent someone from accidentally energizing the circuit while someone is working on it. Let us now delve into the different types of service disconnects available. There are several types of service disconnects, each with its own advantages and disadvantages. One common type of service disconnect is a circuit breaker. Circuit breakers are reusable devices that trip and interrupt the circuit when an overcurrent occurs. Circuit breakers are available in a variety of sizes and ratings to meet the needs of different applications. Another type of service disconnect is a fuse disconnect switch. A fuse disconnect switch combines a disconnect switch with fuses for overcurrent protection. Fuse disconnect switches are often used in commercial and industrial applications. A third type of service disconnect is a safety switch. A safety switch is a manually operated switch that is used to disconnect power to a circuit. Safety switches are often used in industrial applications where it is necessary to quickly disconnect power to a machine or piece of equipment. When selecting a service disconnect, it is important to consider the following factors. Firstly, the ampacity of the service. The service disconnect must be rated for the ampacity of the service that it protects. Secondly, the voltage of the service. The service disconnect must be rated for the voltage of the service that it protects. Thirdly, the interrupting rating of the service disconnect. The interrupting rating of the service disconnect must be high enough to interrupt the maximum fault current that could occur at the service. Fourthly, the environmental conditions. The service disconnect must be suitable for the environmental conditions where it will be installed. Another crucial aspect to consider is arc flash protection. Arc flash is a dangerous phenomenon that can occur when there is a fault in an electrical system. An arc flash can produce extremely high temperatures and can cause serious burns or even death. The National Electrical Code requires that electrical equipment be labeled with arc flash hazard warnings. It also requires that workers wear appropriate personal protective equipment when working on or near energized electrical equipment. There are several ways to reduce the risk of arc flash. One way is to de-energize the equipment before working on it. Another way is to use arc flash rated equipment. A third way is to increase the working distance from the equipment. In addition to the National Electrical Code, there are other standards and regulations that may apply to electrical installations. These include state and local codes, as well as standards from organizations such as the Institute of Electrical and Electronics Engineers and the National Fire Protection Association. It is important to be familiar with all of the applicable codes, standards, and regulations before starting any electrical work. In summary, understanding the historical context of electrical codes, specifically regarding service disconnects, is crucial for ensuring safety and compliance in older buildings. The shift in the 1975 National Electrical Code to require readily accessible service disconnects outside buildings significantly improved safety and ease of maintenance. While older installations may have been compliant at the time of construction, they may not meet current standards and should be evaluated for potential upgrades. Consulting with a qualified electrician is essential to determine the most appropriate and cost-effective solution for bringing an older electrical system up to current code. Remember that electrical work can be dangerous, and it's important to always follow safe work practices. If you are not qualified to perform electrical work, it's best to hire a licensed electrician.